Let's talk about a problem. This one involves a mouse sitting on a cheese block, maybe snacking on it, and suddenly it sees someone and it wants to just run and hide, so it jumps off this cheese block. So we'll assume that the mouse takes off to the right with a speed v0 with respect to the ground, and now we are asked to find what happens to the cheese block afterwards. So you can imagine when the mouse jumps off, its legs are going to kick the cheese block back, and then because of that it's going to go back first and then compress the spring, and then the spring is going to push the cheese block back, and it's going to go back and forth executing simple harmonic motion. And the aim in our particular problem is to find the function x of t for the block after the mouse jumps off. So that's our ambition. Now the first thing that we have to think about is what is conserved in the process of the mouse jumping off the cheese block. Well, the process of jumping off is actually a pretty energy intensive process, and so energy is lost due to the internal aspects of the mouse, muscular energy and so on, so we cannot conserve energy. We have to conserve momentum instead. In the x direction, because this floor is frictionless, there is no external force. So sigma fx x equals 0, and that tells us that the initial momentum, sum of all the initial momentum, is equal to sum of all the final momentum in the x direction. Now initially neither the mouse nor the cheese were moving, so that's 0. And then at the end the mouse was moving to the right, so that's positive mv0. And we don't know what the initial speed of the mass is. Let's call that v here. It has to be in the backward direction. But if you don't believe that, you can always look to momentum conservation to deduce that. So that's going to be mass times v. And when you solve this, I get v equals negative little m over capital M v0. And that indeed confirms what I said, that the direction of v is opposite the direction of v0. Now this is one-dimensional, so negative sign means a vector in the opposite direction. So we have the initial speed of the cheese block. Now remember, this is the speed, the maximum speed that the cheese block will ever have, because the moment it goes to the left, it starts compressing the spring, and so it starts slowing down till it stops, and then it's going to come back here, get the speed v back in the opposite direction, and then keep going to the right, and then slow down again. So let's call the amplitude on either side. On either side it's going to oscillate between these 2 points. So if we call this 0 here, that will be the amplitude A, that will be the amplitude minus A. So we are shooting to find what A is. For that, we can actually use energy conservation, because after the mouse has jumped off, energy is conserved for just the cheese block. So what happens here is that the maximum kinetic energy of the cheese block at this position gets transformed into potential energy at the extreme position. So I'm going to write 1/2 capital M capital V squared equals 1/2 K times A squared. Now it does not matter that it's negative A because I'm squaring it. So let me now solve for A. A is going to be the square root of M over K times V, with V just being the positive value of that. So let's substitute from there. I'm going to get square root of M over K times little m over capital M v0. So that's our result. Now the last aspect of finding the equation of this has to do with the phase constant. So let's first write the equation for now. X of t for the cheese block is going to be a times cosine omega simple harmonic times time plus some phase constant phi. That's a general form of the equation of any simple harmonic oscillator, as I showed you in the introduction to simple harmonic oscillation in one of the videos last week. This is called the simple harmonic oscillation frequency, measured in radians per second. That's time measured in seconds. That's the amplitude measured in meters, which we just found here. And that's a phase constant measured in radians. So we have to determine this phase constant. Now, one good way to do that, by the way, omega simple harmonic for this particular problem is going to be the square root of k over capital M, because that's the oscillation frequency of any block spring system. So I already have that with me. Now, to find the phase constant, a good thing to do is to differentiate this to find the velocity. So I'll write dx by dt. So that's negative a omega simple harmonic sine of omega simple harmonic times the time plus phi. Let's ask what happens at time t equals 0, because that's the moment we're going to assume that the mouse jumped off the block. So at time t equals 0, let's write down what we have for x of t and v of t. X of t is going to be a times cosine phi, because this is just 0, and v of t, t equals 0, so v of 0 is equal to negative a omega simple harmonic times sine of 0 plus phi, so it's just sine phi. Now let's think a little bit. At x of 0, the distance was 0, because we chose this to be our origin. So this is 0. This tells us that cosine can be one of two things. So cosine phi has to be 0, which in turn means that phi has got to be either 90 degrees or 3 pi over 2. So either 90 or 270 degrees gives you the result that cosine phi equals 0. Which one is it? That's the thing we need to find next. Now observe that when the mouse jumps off, the block goes to the left. So we need the initial speed of the block to be negative. Now this velocity already has a negative sign in front of it thanks to that result. So this is less than 0 only if sine phi is bigger than 0. And sine phi is bigger than 0 in the first quadrant. This is the third quadrant where sine is negative. So that's the correct phase. So you have to look at both the position and the velocity in order to determine the correct phase. Now once we have done that, it's just a matter of putting everything in and declaring that to be our final answer. So let's do that. So the final answer is x of t equals the, let me make a small, I don't really need to do that. Let me just write down what I see there. Square root of m over k times little m over capital M times v naught, that's the amplitude, times cosine of omega simple harmonic, which is the square root of k over capital M, t plus pi over 2. Now that is our final result. That tells us how describes mathematically how the cheese block will oscillate as a function of time.